Assalamualaikum warahmatullahi wabarakatuh. Here is a quick summary on the estimation process, which you have seen throughout this chapter. So first of all, we have discussed the point estimation and interval estimation. And if you want to relate to what you have seen in chapter 1, okay, which is the introduction to statistics, well, you will see that when you are interested in the population mean or in the difference of the population means, then you will see that the variable considered in this case is continuous. So that is the sort of the link between what you are doing in this chapter with what you have seen in chapter 1. And if you are interested in the population proportion, or in the difference of the population proportions here, then you are actually dealing with a categorical variable or qualitative variable, which can be reduced to being dichotomous. So dichotomous means you have two outcomes, okay? Right, now this conclusion is a bit general, and I feel that I need to do a more specific conclusion, which is going to give you some sort of a bigger picture of what you have done in chapter 2. Okay, so that is my point. In this video, I'm going to paint the whole picture of this chapter on estimation. Yep. Okay, so now what we have done so far is this chapter is about estimation. So this is about estimation, and we have seen that there is a point estimation and interval estimation. So we have done point estimation and interval estimation. Okay, so I'm just going to write down here. We have done, for example, point estimation and interval estimation. Right, so for point estimation here, there are a few examples that we have discussed. For example, what is the point estimation for mu? What is the point estimation for P, which is the proportion? What is the point estimation for variance? What is the point estimation for standard deviation of the population? And we also have discussed the point estimation for population central tendency. Okay, I'm just picking up one example here. And the answer to all this is okay, so the answer to all this is for mu, the point estimation is going to be x bar. For proportion, the point estimator is p hat. For population variance, the point estimator is s squared. For standard deviation, the point estimator is s. Now for population central tendency here, you may have more than one point estimator. Okay, so you may have, you can choose the sample mean, which is x bar. You can choose the sample median. You can choose the sample mode. Okay, so these are the possible options, for example, depending on the situation, of course. And whenever you are presented with more than one point estimator, this will give rise to, so this will then give rise to the problem, which is to choose what is the best point estimator. So in order to choose the best point estimator, there are three characteristics that you have to tick off. So the first one is it has to be unbiased, it has to be efficient, and it has to be consistent. So basically these are the ideas which we have discussed that is related to point estimation. So now we are going to look at the interval estimation. So in interval estimation, we have the case of one population, and we can also extend to having two populations. Okay, so one populations and two populations. So in one population here, you may be interested to know about mu. So you may be interested to know about mu, and another case that you have looked at is to know about p. So mu and p. Okay, so this is mu, and this is for population proportion. Now for mu, you need to further consider whether the population variance sigma squared is known or whether it is unknown. I think what I'm going to do is I'm going to erase this part first. Okay, so for mu, there will be two cases that you need to consider. The first one is sigma squared is known, and this one is sigma squared unknown. Okay, so let us talk about sigma squared known first. So when sigma squared is known, the formula to find the confidence interval is going to be x bar plus minus z alpha over 2 sigma over square root n. So this is when sigma squared is known. So when it is known, we will resort to using the z quantile from the standard normal distribution table. Now when it is unknown, I'm just going to do some bit of detour. So when it is unknown, sigma squared is unknown, then the formula to find the confidence interval is going to be x bar plus minus t and minus 1 alpha over 2 s over square root n. So basically when it is unknown, you will resort to finding the t quantile that comes from the t distribution, and of course instead of writing sigma, we will write s. So s here is the sample standard deviation, so you have to estimate the value of unknown using s. Okay, alright, next is in one population, you might also be interested to find the confidence interval for population proportion here. So in this case, for population proportion, provided that the sample size is large, then the confidence interval for the population proportion is given by this formula. So p hat plus minus z alpha over 2, and here is p hat q hat over n. So this is the formula for finding the confidence interval for proportion. Right, so we can make the problem more complicated by considering two populations here. So if you have two populations, again you will have the problem of finding the difference in means, or you might be interested to find the difference in proportions. Okay, so for the first case of finding the difference in means, Okay, I'm just going to box it. So right, and for the difference in means, there will be some other factor that you need to consider, which is, are the samples independent or is it dependent? So samples can be independent or dependent. Next, if the samples is independent, let's say the samples is independent, is the variance known or is the variance unknown? I don't know whether this is clear or not. Let me just properly write it down. So this could be variance known and variance unknown, right? So in the case of variance known, so if the variance is known, therefore the formula for the confidence interval is going to be x bar 1 minus x bar 2. So variance is known, which means we are going to resort to standard normal distribution table. May I just write it over here? Oh, never mind. Okay, so it will be z alpha over 2, and this one is going to be the population variance plus another population variance from the second group. So that is when variance is known, the population variance is known. Okay, so next is, if the population variance unknown, okay, so I'm just going to use this root. So if the population variance unknown, but it is assumed to be equal, unknown, but it is assumed to be equal, therefore the formula for that one, the formula for the interval estimation is going to be x bar 1 minus x bar 2 plus minus t n minus 1. Sorry, not n minus 1. This will be the combination of sample sizes from two groups, which is n1 plus n2 minus 2 alpha over 2, and this will be the pooled standard deviation, and this will be 1 over n1 plus 1 over n2. So this is assuming it is equal. Now there is another case where it can be unequal. So it can be unequal. So if it is unequal, then the formula for this one is going to be, bear with me. So if it is unequal, then the formula for that one is going to be x bar 1 minus x bar 2 plus minus t. So the degrees of freedom here will depend on which one is the smaller between n1 minus 1 or n2 minus 1. So alpha over 2. Next, it will be s1 squared over n1 plus s2 squared over n2. Okay, so that's the formula when you assume sigma square unknown and unequal. Okay, right to this part. All right. Next, you might also be interested to find the difference in means, but your samples are dependent. So samples are dependent. So therefore, the formula to find the confidence interval is going to be d bar plus minus, it will be referring to the t distribution, n minus 1 alpha over 2. This is the standard deviation for the new data. D here is the new data where you find the differences between the two data sets. This is over square root n. Alright. Now, next, we might be interested to find when you have two populations, and if your data is qualitative or dichotomous to be specific, maybe you are interested to find the difference in two proportions. So the difference in two proportions, provided that n1 and n2 are large, so large. The formula to find the difference in proportions are given by this one here. So it will be p1 hat minus p2 hat plus minus, we are going to use the standard normal distribution for this one, and it will be p1 hat q1 hat over n1 plus p2 hat q2 hat over n2. Okay, and you will see that this one is the type of variable is categorical. For this one is continuous. Whenever you want to find the means, the variable has to be continuous. Okay, so similarly for this one, in order for you to find the mean, of course the variable is continuous, whereas for proportion the variable is categorical in nature. Well, I think this simple diagram has successfully summarized what you have seen in this chapter, and I hope that by looking at this you are able to connect all the important points, and able to organize your thoughts, and you will be have better understanding of this topic. Okay, thank you very much for watching.